Alright, so today we're going to talk about difference quotient. Difference quotient is kind of a zoomed out view of average rate of change. So before we start, let's do a quick warm up to refresh ourselves on average rate of change. So find average rate of change, again we abbreviate that usually ARC, of the function f of x equals 7x squared plus 4. Let's say from x equals 1 to x equals 3. Average rate of change, remember our formula for that was f of b minus f of a over b minus a. Right? A and B just being the endpoints of where we were looking at. It didn't matter which order we put them in. So here I'm just gonna choose A to be 1. So that means that we've got f of 1 and 1, replacing A over here, and then B will be 3. So we've got f of 3 minus f of 1. Now, how do I move forward? Well, we just replace less useful things with more useful things, right? So what is f of 3? Well, we can figure that out by plugging it into f, right? F of 3, I've replaced x with 3 here, so I need to do the same thing on this side. So I have 7 times 3 squared plus 4. So 7 times 9. Plus 4, which 7 times 9 is 63. 63 plus 4 is 67. So f of 3 is 67. Now we need to find f of 1. What is f of 1? We do the same thing. We replace x with 1. So we have 7 times 1 squared plus 4. 1 squared is 1. So we have 7 times 1 plus 4. Which is 7 plus 4, or 11. So we end up with 67 minus 11 over 3 minus 1. 67 minus 11 gives us 56. 3 minus 1 gives us 2. So this tells us that our average rate of change is 28. How does this extend into difference quotient? What is difference quotient? Let's look at a graph again. So before, with average rate of change, we were finding the slope of the line between 2 points on a graph. So, for instance, points A and B. Right, we were finding the slope of this line because the slope of this line told us how much our output values were changing as our input values get larger, right? So, but that's very specific, right? That means we have this average rate of change for this very specific set of points on this graph. How can we make this a little bit more general? So again, ARC was f of b minus f of a over b minus a, right? Change in y over change in x. So now, let's make this a little bit more general. So instead of calling this x value a, we're going to call this now x. Our new name for that guy is x. So x is a. Now, b, what we're going to do for difference quotient is instead of calling b b, we're going to say, okay, well, I know that b, or this point, is h away from x. B, the distance between A and B is h. Between x and this second point is h. So then what does that mean that our second point is called? Well, should be x and then h more, so x plus h. So now b is x plus h. So we can rewrite our average rate of change as f of x plus h, right? B is x plus h, so we're just replacing it here, minus f of x was a, over x plus h, right? That's b again, minus x. Can we simplify this at all? We can't really do too much on top. If something's inside of the input of the function, right inside the parentheses, we can't take it out or do anything with that. So we can't really do too much on top, but we can simplify the bottom here, right? These parentheses aren't doing too much because these are just added to each other. So we can take the parentheses out. If we take the parentheses out, we're just left with x plus h minus x. So we have a positive and a negative x, right? If we subtract something from itself, it just becomes 0, so we're just left with h. So this is equal to f of x plus h minus f of x over h. This is what we're going to call the difference quotient. So the way we're going to find the difference quotient, because this is not super fun to do all at once, is we're going to kind of split it into steps. So finding the difference quotient. I'm going to write it over here so we can kind of reference. So we have f of x plus h minus f of x all over h. So the first thing we're going to want to do is find f of x plus h and simplify. Pretty much every time you see difference quotient, it's going to ask you to simplify. So we're going to simplify throughout the problem so that we're not left with a whole bunch of stuff to simplify at the very end. I'm going to use a different color here to show what we're doing. So step 1, I'm going to show that in purple. So finding f of x plus h, that's this guy. So again, this is step 1. Is just finding this. Once we find that and simplify, we want to subtract f of x and simplify. Again, we're simplifying at every step. So subtracting f of x, that's this part, right? So we've found this first part, we did step 1, and then we subtract f of x from that first part. So that will give us this all together. And then last but not least, we want to divide each term. And I'm going to underline each term by h. And of course, simplify. So once we do step 1 and step 2, we get all of that together. Step 3 is to divide by h. that will give us the whole difference quotient. Okay, let's use those steps to look at actually the example we looked at for average rate of change. So let's find the difference quotient of f of x equals 7x squared plus 4. Same problem we looked at for average rate of change. So find the difference quotient of f of x equals 7x squared plus 4, and simplify. All right, so we want to take it step by step. So our first step, 1, was to find f of x plus h. F of x plus h. So again, as always, this means I need to take whatever's on the inside here, right, and plug that in for x. So I've replaced this x with x plus h, so I need to replace this x with x plus h. So what is that equal to? 7 times x plus h all together squared. Definitely important to have parentheses here so that we know that we're squaring x plus h. Then plus 4. Again, what we've done is, right, we've got x plus h. That's what we want to input into our function. Our function tells us that whatever we input, we have to square it, multiply 7, and add 4. So we are taking exactly that, right, x plus h, squaring it, multiplying by 7, and adding 4. All right, when I square x plus h, what do I have to do? It's a binomial, so I have to FOIL, right? Remember, x plus h squared is x plus h times x plus h. When I square it, I get first outside, inside, last, right? FOIL. So first gives me x squared. Outside gives me x times h, but inside also gives me x times h, so I have 2x times h. And then last gives me h squared. Now I have to multiply this 7 by every term here, right? That's why it's important that we had our parentheses. So I have 7x squared plus 14xh plus 7h squared plus 4. Now that is as simplified as I'm going to get. Okay, so my next step was to find f of x plus h and subtract f of x. That means I need to take this, right? F of x plus h is all of this. So we had 7x squared plus 14xh plus 7h squared plus 4. And I'm subtracting f of x. F of x is 7x squared plus 4. Okay, so for some folks it helps to have this written out without the parentheses so they can see what's happening with the signs. So minus 7x squared minus 4. Right, we need to make sure we distribute this negative to each term here. So how does this simplify? What can we do? Well, as I go along through, looks like I've got a negative 7x squared and a positive 7x squared, right? Those guys are going to add together and give me 0, so they can kind of cancel. Similarly, I have a positive and a negative 4, so these guys can cancel as well. If you can see that we have the same matching terms over here, but they're being subtracted, you can cancel from this first line. You don't have to write out this second line, but for some folks it's helpful. So, you only have to do what's helpful for you. Okay, so that leaves us with 14xh plus 7h squared. So that is the numerator of the difference quotient. My last step is to divide each term by h, right? So our last step, which is all of this together, right, is to divide every term by h. So first term is 14xh divided by h. Second term is 7h squared divided by h. These h's are going to cancel. Because I have 14 multiplied by x multiplied by h and then divided by h, multiplying something by h and dividing it by h cancels out, right? Multiplication and division kind of undo each other, so these guys cancel. Similarly here, we have 7h squared, which is 7 times h, right? So again, one of these multiplying by h's will cancel with this h on the bottom. So we end up with, right, just regular 7h. So my answer is 14x plus 7h. This is the difference quotient of f of x. Okay, so now that we've found that, awesome. What the heck does it mean? This is the average rate of change from any point x to another point that's h away from x. How does this help us? Well, if we're computing a bunch of average rates of change, it makes things faster. And in calculus, you're going to have to do that. So let's see an example of how this can help us. So what is the average rate of change of f from x equals 1 to x equals 3? Well, remember from our warm-up, we found that the average rate of change from 1 to 3 for this function was 28. So let's see if we get the same thing. So here, right, before we let a be 1 and we let b be 3, with difference quotient, we said, okay, instead of calling a, we're going to call it x. So x is 1, and then b was h away from x. So 3 is how far away from 1? What's the distance between 3 and 1? It's 2, right? We can see that by letting, remember we said we were replacing b with x plus h, right? So x plus h is 3, but x is 1. That means that h is 2, right? It's just the distance between a and b. So our difference quotient tells us that the average rate of change can be found from a to b can be found by plugging in 1 for x and 2 for h into this equation. So we have 14 times 1 plus 7 times 2, which gives me 14 plus 14, which is 28. And now this is a lot faster than having to calculate all of this stuff, right? So this is very helpful for us. Okay, let's go ahead and look at this in our lab manual. This is the section difference quotient of a function. Let's say we're looking at g of x equals 3x minus 5. So g of x plus h, again, we just want to plug in what that is into the function. If g is 3x minus 5, then g of x plus h is 3 times x plus h. We keep those parentheses plus 5. Again, we want to simplify. We need to distribute this 3 to each term. So we have 3x plus 3h plus 5. Our next step, we want to subtract g of x from that. So we are starting with 3x plus 3h plus 5 and subtracting again 3x minus 5. We know that we have the opposite sign for 3x, so these guys are going to cancel. We've got now opposite signs here, so we know that 5 plus 5, right? This subtraction and subtraction is going to become addition, is going to cancel. So we're truly just left with 3h. Now our last step to get the full difference quotient was just to divide each term by h. So we just divide this by h and we get 3. So the difference quotient for this function, this line, is just 3. Okay, why don't you guys try number 2? Okay, so this question was very similar to the previous one, right? We had kind of all the same steps. We had to plug in x plus h and distribute that coefficient. Then we subtracted and we had a lot of cancellations, right? And we were just left with 6h. Then we divided 6h by h and we're left with 6. All right, the next one I want to look at is on the next page. I want to look at number 10. So v of t is 3t squared minus 2t plus 1. We want to find the difference quotient. This time it doesn't necessarily lay out all the different steps for us, but we know what our 3 steps are. So we have v of t. So before, our first step was to find f of x plus h for the function f of x, but now we're working with v of t. So here we're going to find v of t plus h. Totally fine. So we plug in t plus h for t. We replace all the t's with t plus h. So we've got 3t plus h squared minus 2t plus h plus 1. We need to simplify, so we have 3t plus h squared gives us t squared plus 2th plus h squared. Then we're subtracting, we'll save this for the next round. So now we distribute these coefficients inside of the parentheses. So we have 3t squared plus 6th plus 3h squared minus 2t minus 2h plus 1. Lots of distributing. Now we want to take this and subtract v of t, right? That's our next step. Step 2 is to subtract v of t. I'm just going to write it on the end here now that we've found it, right? So this is step 2. Subtracting v of t is 3t squared minus 2t plus 1. We have 3t squared and 3t squared, but this one's getting subtracted, so this guy cancels. We have minus 2t and minus 2t, but this one's getting subtracted, which will make this addition. So these guys cancel. And we have plus 1 and plus 1, but subtracted, so these guys will cancel. So we have left 6th plus 3h squared minus 2h. My last step is to divide everything by h. So I divide by h, divide by h, divide by h. These h's will cancel. These h's will simplify, right? So these can kind of undo each other. This h underneath will cancel with one of the two h's on top, so we are not squared anymore, we just have 3h. And then 2 times h divided by h, multiplication undoes division, so these h's undo each other, and we are left with 6t plus 3h minus 2. This is the difference quotient for 10. Okay, let's look up here at number 12. So we've got 2q squared minus q. Again, we start with f of x plus h, so here that's going to be r of q plus h. We're replacing q with q plus h everywhere there's a q, so we have 2q plus h squared minus q plus h. Q plus h squared gives us q squared plus 2qh plus h squared minus q plus h. We distribute this 2 everywhere, so we have 2q squared plus 4qh plus 2h squared minus, this subtraction needs to distribute. So we're starting out with r times q plus h. We've simplified, so now we want to subtract r of q from that. So 2q squared minus q. So we have 2q squared, but this one's being subtracted, so these guys will undo each other. We have q and also minus q here, but this subtraction will turn this into a plus. So we have minus q plus q, so these two will undo each other. So we're just left with 4qh plus 2h squared minus h. And last but not least, we divide every term by h. So it looks like we're left with, these two will undo each other for that term, so we have 4q. This h will undo this h squared, right? One of these h's up top. So we're left with 2 times 1h instead of 2 times 2 h's. And then minus h over h, what's something divided by itself? Like 2 over 2 or 6 over 6 or negative 27 over negative 27, just 1. So this is my difference quotient. Those are the only kind of functions that we're really going to see difference quotients for. There are different types of functions here, but we only really need to focus on these guys for now. Yeah, thanks for watching.